Hi, software engineers. Time to continue talking about architectural design patterns. I know it sounds exciting, but trust me when I say, once you get good at this stuff, that's when you really start becoming a software engineer and you can start building some really, really cool stuff. So what we're going to talk about today is Model View Controller. Now, you've probably heard of Model View Controller before. It could be something that you've seen just surfing the internet, could have been maybe on a package or a library in GitHub that you saw and you're like, ooh, MVC, this sounds very exciting. Maybe this is something I want to use. Well, let's talk about what it means. First, let's review. What's an architectural design pattern? Well, remember that a design pattern is an accepted solution to a known problem, okay? We don't want to keep redoing stuff, reinventing the wheel in software engineering. Once we figure out a good way to build software, once we figure out a good way to solve a particular problem, let's keep doing that. That's a good thing. Now, the difference though is that that solution needs to be applicable in different programming languages or maybe in different environments. So a pattern doesn't have code. It doesn't have, this is the exact way that's going to work. It is this generalized example. It's going to omit some implementation details, but it's going to be this guide to help you say, oh, I can kind of see how this problem is formulated, so maybe this is the way I should try to solve it. Now, you've probably heard the term design patterns also, things like adapter pattern or visitor pattern or factory pattern. We're going to get to those, but we're starting or continuing, I suppose, with these architectural design patterns. And you talked about some with McBurney in previous videos, the idea of three-tier or a layered architecture. And we're going to get into those this week. So let's first focus on the notion of a three-tier architecture. We have this really, really common problem in software design that says we need to have something the user can use, some interface. We need the actual thing that knows what the data, how to manage the data itself. What are the business rules? And then how do we store the data? So this problem comes up all the time. It became more impressive of a problem as we got into web technology and also mobile technology, because people were building applications that would then live in a web application, and then they say, oh, but we need a different user interface for this to work on mobile because the mobile has a smaller screen. So we need a different user interface layer. Oh, okay, let's figure that out. Or something like, hey, we've got this working for MySQL, but we need to port it over to Postgres. How much code do we need to change in order to do that? Well, if your three tiers set up right, it doesn't really matter. You can actually switch those things out. So while the notion of a three-tier architecture can apply to anywhere that you can see the presentation, the application, and the data, for instance, a web browser, a web server, and a database, what does it look like when we get really down to the code level itself? So what would a pattern look like that solves this problem? We want something that allows for change, where we can go in and if we make a change to part of the code, it doesn't create those ripples like we talked about in previous videos. We want it so that we can reuse components. If we build a really nice user interface, we might want to use some of those in a later piece of software. Again, we don't want to keep reinventing the wheel. We want to build the software and just use it and maintain it and make best use of our time. If we know that other people have built a component that works really well, maybe we want to integrate it, something like Square payments, or maybe something like Twitter, or, other social media, or login. Have you been working on integrating login into anything? Well, if we have a good pattern for this, we can split our team up and say that, oh, okay, this team is responsible for login and this team is responsible for the data. And as we agree on how those things are going to talk together, then it makes it so much easier to build larger systems. So we need a good pattern. Model View Controller is a pattern that came about from the concepts of three-tier. At its simplest level, model is the data tier, view is the presentation tier, and controller is the logic or business tier. Okay, so why do we need a different name for it? Well, when we use the term Model View Controller, we tend to be talking specifically now about code. Model View Controller originally came about in the programming language Smalltalk. And if you've never heard of it, there's a reason. Now, Smalltalk is actually a precursor to Objective-C. That's a whole other conversation that we can get into when talking about how Apple ended up designing their language. But Smalltalk was really important as a programming language because it was the first programming language that really leaned on a usable, needed IDE, because it had a visual component to the way you programmed the language, and you actually could associate things with a model, a view, and a controller. So it evolved, obviously, as languages went on, and we didn't hear a ton from MVC. I mean, it was still there. It just wasn't as prominent until we got to web development. Once we got to web development and mobile development, model view controller became increasingly important because we wanted to be able to swap out the presentation layer, swap out those view layers to maybe we want our website to sometimes show HTML, but sometimes we want it to output JSON or XML because it's trying to export that data to another system. So model view controller as a pattern gives us the ability to do all that. Once that became more important, we started to see a rise of frameworks that provided model view controller functionality or organization of your code without you having to know a ton about what's going on. Things like Django, Ruby on Rails, Cake PHP. There's a whole list of these. We're actually going to explore some of these in the guided practice this week. So what does MVC look like? Well, there you go. You have a model where the data lives. Okay, so what's important about a model is that it is an abstraction of the data. We'll talk about that in a minute. The user interacts with a controller, which has the business logic, which then gets data from that model that we just mentioned, and then brings that into a view so that the user can interact with it. Now, a nicer picture for this, particularly for a web application, looks like this. So here we have a browser that is sending a request to a web server, and that web server takes the URL that comes in and then interprets that URL as a part of the controller. Here, there's a router and dispatcher. In Django, remember you have the URLs file? That's what this is doing. It takes the URL and says, oh, okay, it's not an actual URL. It's not, in your project, you don't have a /list folder or whatever function you're creating. It actually is interpreted as a function call. And this is part of what the MVC frameworks give. Again, we're going to talk more about this throughout this week. So the controller takes that URL request and says, the user is interested in my application /students/list or something along those lines. So I need to get the students model, and I need to get all of them, and I need to get the view that lists them. So it goes to the model and says, hey model, I need all of the students. The controller doesn't care what the model does. The model that's written just says, okay, I need to get the students. And depending on the framework, it's just going to say, okay, I know how to do the SQL. You haven't had to write any SQL for your project yet. Although you still have had to deal with things like make migrations and jazz like that, which admittedly is not amazing and fun, but you don't have to deal with actually writing the code that says select asterisk from table. The model does that. And that's what we want. So the controller says, I need all of the students. Great. Now I need to know how to view it. Okay, in Django, it's going to go to the view and it's going to go to your templates, which confusingly enough are the view and the views are the controller. We'll talk about that in a second. And then builds out that page that then gets sent back to the user. So it's this really tight, interesting way of designing a website where you have a separation of concerns. You put all of your HTML, your templates in one folder. You put them where you could have UI designers working on those separately. You put your data in these model classes where the framework handles the database. You don't have to manage the database, thank goodness, other than to make migrations every once in a while. And you say, this model relates to this other model in this way. Easy peasy. And then you write the code, as in the controller. The controller is what is what the application is. It's the thing that drives how this thing actually operates. So, the controller. The controller is effectively a traffic cop. Okay, a request comes into the controller. The controller determines how to handle that request, and then makes the appropriate calls to the views and to the models so that it can generate the appropriate information that goes back to the user. So, in a website, this makes it's easier to understand. In an Android app, let's say if you've done Android, this will make sense. If you haven't, I'm sorry, but if you've done Android, there's these files called activity files, and an activity file is a page on a Android app. Okay, and in an Android app, to do the user interface, there's an XML file called layout, and the model there is a database, SQLite, or it could be like a text file, but it's typically something like SQLite that the activity file knows how to load. So it's super easy also in an Android app to say, I need a new screen. I'm going to make a new activity, which is a new controller, which is going to manage the functionality for that app, for that page. And then it's going to load the appropriate option. The model is where the data live. Or more accurately, it's where a representation of the data live. In an ideal world, you, application designer, don't need to worry about writing SQL code. Do I think you should learn SQL at some point? Yes, I think you should, because it's still relevant, yada, yada, yada. But when you're building an application, you want to focus on, this is the data I'm working with, not what's the right join of these tables to get the work. You don't want to deal with that. You want to deal with, I need a list of this. Give me. That's it. So a model is an abstraction. It allows the programmer to step back from the data representation at the bit level, how it's stored on disk, and work with what the data actually is. So, this is the class definition with a DB backing system. And then the view is, well, it's an HTML template. It is an XML file that shows what the user interface. It is just the user interface. It's whatever the representation is in the language that you're using. It could be XML. It could be swing classes for that matter. But all of your UI components live in that. Django is an MVC framework. It's a free and open source MVC framework that's written in Python. Now, I hate this part of Django. Model is model. Awesome. View in Django is controller. Uh-oh. Template in Django is view. Okay. That's kind of painful. I honestly, a couple of years ago, wanted to use Ruby on Rails for this class just because they're called models, views, and controllers, and you don't have to have this conversation. But this is the conversation we have. Models are models, views are controllers, and templates are views. But you can figure that out when you look at the code, right? Your template, that is the HTML. That's the thing that's going to that generates the actual page that goes back to the browser. The view is where you put all the interesting bits to make the program do what you want it to do, and the model is the model, right? Django is a framework that is convention over configuration. So basically, if you follow the rules and name methods the things you should, and name files the things that you should, magic happens, and you don't have to program everything. This is very common in different MVC frameworks because it allows the programmer to theoretically get more done faster without having to program all of the little nitty-bitty things. So not a bad thing. It is just something you have to get used to, and it doesn't want you to repeat yourself. It wants you to reuse code throughout the system. Now, Django is a known, used framework that is, here are some examples that use Django. It is not a small list, and the list continues to grow. We are not teaching you a framework that is completely, dead by any stretch of the imagination, but it does bear repeating that this is something that, like all frameworks, new things will come in, things will leave, and it's always an evolving ecosystem. So again, in Django, the model, you create the model files. We'll look at one in just a second. You've seen some, obviously. But you can choose the database. Now, we're telling you need to use Postgres. And the reason we're using Postgres is because that's the default database that Heroku uses. But by default, Django uses SQLite. SQLite is an embedded database, which doesn't behave the same way as Postgres. That's not a good or a bad thing. SQLite is amazing for certain things, but for our purposes, it's not optimal, which we can get into in a later video. So you define the models as a Python class, you inherit from the model itself, and then in order to sync up your models that you create with the database that needs to be there, that's what Make Migrations does. Whenever you create a model, some new models, and you move them around or make changes to it, you need to tell Python, or you need to tell Django, excuse me, hey, new database stuff, go update. Go make sure you can handle all this. That's what Make Migration does. So again, the model looks like this. Looks very similar to the way you would define a database table, except we're doing it inside of Python. A model ideally is going to do everything that you would want a normal SQL table to do. Things like manage relations between tables to say something like, if a student exists, they must have registered for at least one class. You can embed some logic into that, some foreign key dependencies, for instance. But you do still have to continue to make sure that you follow the Django conventions, because if you don't, the tables are not going to get created properly. Now, the controller in Django are the views. It is horribly confusing. But the idea is that the controller is going to accept an HTTP request, and then it's going to return with a response. And that response will be a packaged HTML that the web browser will then interpret. Well, it doesn't have to be HTML. It depends on whatever the template is telling you to do. Talk about that in a second. But that response could be very simple. Like, for instance, right here, you could define this request that just packages up an HTTP response and just sends it back. Doesn't even have to load a template if you don't want to, but you probably want to. So these views are going to process the parameters from the URL. So anything after the base URL, /something/something/something, all of those are treated as parameters that come in, and then you use that to then call the appropriate view, load the appropriate model, call the appropriate template, load the appropriate model, and build it to send back what you need to send. So the templates that you deal with in Django, it's kind of a mix of HTML and scripting language so that you can generate the appropriate HTML on the fly. These are generated web pages. Every time the web page is accessed, it is regenerated every time. So if the model changes, if data changes on the back end, new page is generated. So as you see here, for every for the length of packages, for every package in the package list, put out the name, print it to the screen. We're building a URL just like that in the for loop. You've been playing with this up to this point. Now, there's nothing that says, though, that you have to put this in HTML. Let's say you make a web page that you want to spit out JSON. Someone goes to your URL /student/list, and that doesn't give a web page. It gives a JSON object or gives XML, because then you write another app that's going to consume that information, and all of a sudden you've built something called a web service, which we'll get to in a later video this week. But that's the power of an MVC framework. It lets you do things like taking those views and swapping them in and out so that your application can dynamically do different things without rewriting your code base, which is fantastic. So the big picture here, for certain types of applications, like web applications or mobile applications, it's going to benefit from using particular types of architectural models like MVC, so that we don't have to reuse code, so we can build the system faster, so that when someone looks at a system, they say, oh, this is a 3-tier, this is Model View Controller, I know what this is. By the end of the semester, you can probably look at a Ruby on Rails project or a Cake PHP project and basically know what's going on because you know what an MVC pattern looks like. So now, learning this idea, this concept, this design concept, it's preparing you for a whole host of other applications that you could potentially work on. But we don't necessarily want to write an MVC from the ground up. So then we use frameworks like Django or Ruby on Rails or whatever, and use particular coding tools like PyCharm or VS Code that know what all these components are, so we don't have to memorize all of the little ins and outs of the frameworks, and it can generate some code for us so we can build larger systems with fewer bugs, with more people faster. And this is what software engineering is. Learning how to program is great, but learning how all of these larger pieces fit together in order to build something bigger than just one person can do is awesome. And it's fun. So it begs the question, when you look at a problem, how do you know which framework to use? You look at, okay, I think this seems like a problem that needs MVC. Should I use Python? Should I use Ruby? Should I use Java? Should I use something else? Okay, which framework makes sense? Do I use Django because I know it? Or maybe because this is a special type of project, I should use a different framework I haven't looked at? What are some things you should consider? This is what we're going to do in Guided Practice G this week, which we'll explain later on, obviously. But how do you choose a framework? This is one of those kind of software engineer life skills that we want you to pick up along the way. So, my friends, that is MVC in a nutshell. Next time, I'm going to talk about MVC and REST, which is another thing you probably heard, a REST API or something like that. And we'll talk about how REST and MVC work together to create modern web applications. Thanks for watching. Great to see you as always. Bye.